All right, let's jump right in. So when I say software modeling, what comes to mind? Probably dusty diagrams, right? UML charts that never ever match the final code. But what if we could completely flip that on its head? What if we could stop handcrafting every single line of code and instead build a software factory? Yeah, a factory. That's the whole idea behind model-driven software development, or MDSD. It's a totally different way of thinking about how we build software. So here's what we're going to cover. We're going to start with a problem that I bet hits close to home for a lot of you. Then we'll look at this whole software factory idea as the solution. We'll pop the hood and see how it actually works, check out a real-world example to see it in action, and then we'll talk money. You know, the investment, and more importantly, the payoff. Okay, first up, the problem with blueprints. Let's start with something that drives developers nuts. We've all been there, right? You're staring at some UML diagram that's supposed to describe the system, but it doesn't. Not anymore. The code has moved on, a bunch of changes were made, and nobody updated the blueprint. And this quote, man, it just says it all. Many programmers consider models to be an overhead. And they're not wrong in the traditional sense. It feels like busy work, right? Documentation that's basically stale the second you finish writing it. Because when a deadline is looming, what's the very first thing that gets thrown out the window? Yep, updating the diagrams. And that's the fundamental flaw of treating models as just pictures. And that brings us to this really critical difference. On one side, you've got the old way, model-based. Here, models are just documentation. They're passive, and they get out of sync with the code almost immediately. But on the other side, you've got model-driven, and this is a whole different ballgame. Here, the models are the central, active source of truth. They're just as important as the source code, if not more so. It's not a picture of the software. In a way, it is the software. So this leads us to a pretty huge shift in thinking. This software factory paradigm. We've got to move away from this idea that software is this handcrafted, artisanal thing, and start thinking about it more like an automated industrial process. It's time to build a software factory. The key here is moving from all that manual coding to automated production. And in this new world, the model isn't a blueprint anymore. No, it's the order form for the factory. Just think about buying a car. You don't walk into the factory with a bunch of engineering diagrams. You fill out an order form, right? You pick the engine, the color, the fancy sound system. The factory takes that high-level model of your car and poof, it builds it for you automatically. That's exactly what MDSD is trying to do for us with software. Okay, so how does this factory actually work? You know, what's the machinery on this assembly line? It really comes down to 3 key components, and we're going to break them down right now. It's not as complicated as it sounds, I promise. First up, we have something called a domain-specific language, or a DSL. This is basically the factory's custom-made order form. So this isn't a general-purpose language like Java or Python or C#. It's a language that's been tailor-made for a very specific business area. Think insurance claims or banking transactions, or maybe even controlling a giant telescope. The cool part is that it's designed so that the actual experts in that field, not just the programmers, can understand it and use it to describe what they need the software to do. Next up is the Platform Independent Model, or PIM. So once you fill out that order form, the DSL, it creates this universal blueprint. The PIM describes the business logic, the structure, the what, without getting all bogged down in the technical details of the how. It couldn't care less if you're building for a web app, a mobile app, .NET, or some wild new technology that hasn't even been invented yet. This is what makes your core design so portable and, well, future-proof. And that brings us to the real engine of the whole operation, the generator. This is your automated assembly line. It takes that universal blueprint, the PIM, and it just writes the code. All that boilerplate, all that infrastructure stuff that you have to write over and over again for a specific platform, this is where the magic really happens. It frees up developers to stop being code monkeys and start focusing on the really hard, really interesting business problems that actually require their creativity. Okay, that's enough theory. It's all a bit abstract, right? Let's make it real. We're going to look at a super simple but really powerful example, a web app for a car-sharing service. Let's see the factory in action. So check this out. On the left, you've got a tiny piece of our model. It's a class called user registration, and it has one method called finish. Simple enough? Now our generator sees this, and based on the rules we gave it, it automatically spits out the web form on the right, complete with a button that's labeled finish. See that? It's a direct, one-to-one automated translation from the model to the final user interface. But wait, here comes the aha moment.
This is the really cool part. What happens when the business changes its mind? They don't want the button to say finish anymore, they want it to say exit. Well, in the old world, you'd be digging through HTML, CSS, maybe some framework code, but not here. Here, you go back to the model, that single source of truth, and you just rename the method to exit. You hit the generate button again and boom, the application is instantly updated. That right there shows you the incredible power of this for both productivity and maintenance. One change in one place and it just flows everywhere correctly.
Now, I know what you're thinking. This sounds amazing, maybe even too good to be true. And you're right, it's not magic. Building a software factory, well, it takes some real upfront investment. So let's talk about the economics of this whole thing.
The source material is really honest about this. It says there is no free lunch. You have to build the factory before you can use it. Defining that domain-specific language, writing those code generators, that takes serious time and expertise. This isn't some silver bullet, it's a strategic investment. And this chart, it tells the whole economic story in a nutshell. Look, for a single one-off project, building the factory might actually make MDSD more expensive. That initial cost is higher. But the second you start building a second project or a third or a whole family of similar software systems, that's when the investment pays off in a huge way. You're just reusing the factory again and again, and your long-term costs plummet. So let's wrap this up with the key benefits. What do you really get out of this? First, productivity. You're automating all those repetitive coding tasks. Second, quality. The generated code is super consistent and as good as your best developer's handwritten code. Third, maintainability. We saw that in the example, right? Changes are made in one place, the model. And finally, future-proofing. Your business logic is totally decoupled from whatever tech platform is hot today, which means you're ready for whatever comes next.
And that brings us to the end. You know, model-driven software development isn't about getting rid of programmers. Not at all. It's about elevating them. It's about letting them stop being plumbers for tedious infrastructure and start being architects of amazing solutions. So I'll leave you with this to chew on. If you could build a factory for your software, what would you create?